Hi, I'm Rob Saunders. I'm here to talk to you about the Helios project. If you stay with me, you'll learn which one of our team has a Gala clone named after him. You'll learn why trees and photovoltaic panels are similar but different, and why growing apples like grapes may not be as crazy as it sounds. Next slide, please. So when Hutchinsons opened their doors to the fruit growers of Wisbech 82 years ago, typical commercial orchards were planted as half-standard trees, probably planted at 30 foot by 30 foot, about 48 trees an acre, probably interplanted with soft fruit in their early years, or maybe grazed with sheep. Progressive growers would have planted open centre bush trees at 15 by 15 by 15, that's about 190 trees an acre. By the 1970s, intensities increased, and cocks on 106 planted at 7 by 12 was commonplace. Next slide, please. Sarah, next slide, please. So various spindle trees started to appear, and in the 1980s, these were followed by 3 and 4 row beds. Next slide, please. Sarah, thank you. So overall, light interception improved, but ease of management and fruit colour did not, and the demise of effective residual herbicides made them even more difficult to maintain. Next slide, please. So more intensive single rows followed, with a stake supporting each tree. Next slide. And now the orchard design has evolved, and single rows of trees on post and wire are a familiar sight. But what about the orchard of the future? Has evolution shuddered to a halt, or have we reached peak orchard? I suggest we haven't, and here's why. M9 on post and wire, it's productive by historical standards, but they're not without their problems. The vigor means that closely planted trees, there's a tendency for the tree to migrate up the tree for their crop to migrate up the tree over time. And as soon as workers need to leave the ground, crops escalate. The M9 rootstock appears to predispose susceptible varieties to canker. Next point. And the complex and thick canopies are a challenge for machine harvesting. But most importantly, 40% of the sunlight is not utilised. It's wasted. And as the ultimate yield of an orchard is really a function of the amount of sunlight it captures, that is the problem. So that insight set us scratching our heads. How will orchard evolution proceed from here? What will the orchard of the future look like? Now, when the Hutchinsons fruit team get together, the ideas fly thick and fast. We started planning and we started sketching. We wanted to test our ideas on the ground under UK conditions. We knew we'd make mistakes along the way, and we were hoping that we would make mistakes so you don't have to. Next slide. So we decided that to test our ideas properly, we needed 2 orchards, one in the east and one in the west. And this is a drone shot of the heritage site near Newent being marked out. Next slide. So what did we plant? Someone said, why don't we grow apples like pears on a V system? Sloping the trees slightly should reduce the vigour as well as capturing more sunlight. Go on, Sarah. So that's what we did. And this is Sarah. Next slide, please. And this is how they looked a few weeks ago. This is in their 3rd leaf. Cool. Thinking about establishment costs, we wondered how the finances would look if we achieved the same stem density using a more vigorous rootstock managed as a multi-leader. Clearly, it would take longer to reach full cropping, but requires fewer trees. Next slide, please. Someone said, if we're in the business of capturing light, would configuring them like solar panels work? If you look at the PV-GIS website, which is used to predict the output of a panel array at any given location, it will tell you that this orientation, with the rows aligned east and west and leant back, will capture nearly double the amount of light as the same panels aligned as if they were trees on north-south rows. We ran the idea past Mike Hutchinson and he said, I think you're mad, but given our spirit of curiosity and always going the extra mile, go ahead. So that's what we did. And that's how they looked. And this is how they looked a few weeks ago. Then someone said, why don't we grow them like grapes on a guyot with a near horizontal stem and fruits growing upright from it? Next, so there we are. Thanks. Stop there for a second, Sarah. So we were not the first people to think of this, and the genius Stuart Tustin at the Institute for Plant and Food Research in New Zealand is pioneering this multi-leader system. The multi-stems defray the vigor, the fruit is borne close to the stems, the upright elements have very little branching, forming planar canopies that are ready for robotic picking. With closely spaced rows offering excellent sunlight utilization, the yield potential is phenomenal. Next slide, please. So tree ninja Nick Dunn at Frank Matthews grew some trees for us on 116 rootstocks with a kink in them already at the height of the top of the rabbit guards. Next slide, please. And this is how they look today. This is how they looked a couple of weeks ago, with a sloping stem and fruiting units born vertically from that. Next slide, please. So 116 is a really interesting rootstock. It's very resistant to Phytophthora collar rot. It's resistant to woolly aphid, tolerant of apple replant disease, and the cyan wood grafted onto it appears less prone to canker. Interestingly as well, it's strong enough to stand out by itself. And we wondered if it could be the basis of a low-cost, intensive orchard with minimal support. And this is how they looked a couple of weeks ago. So on our Helios sites, we've also planted a range of trial varieties, mostly from Corollas, and we've included a number of Gala clones so they can be compared side by side. This spring, they were joined by Gala 1 and Magma. And don't forget, you can order trees grown by Corollas from Hutchinsons. So, what are we learning? Next slide, please. Naturally, we're recording the yield from each plot. You'll see that out in front at the moment is our alternate leaning V trees just planted at 40 centimeters between the trees and lent outwards. Next slide, please. We're also recording the average fruit size, of course. Next slide, please. And importantly, fruit size distribution. Look at the proportion of large fruit on the PV, on the photovoltaic systems on the two left-hand columns. And also look at the proportion of 60 to 70 millimeter fruit on the 116 minimum support. They're falling right in the marketable range. Next slide, please. So we're also recording the bricks, which you'll know is important for storage and eating quality. Just look at the bricks from the 116 minimal support. And what's really interesting about that is we think that they're slightly later to mature, and all of these were picked on the same day. So the actual bricks potential of that could be even higher than the graph shows. But out in front, of course, was the L-Star from Corollas. Next slide, please. So there's one important piece of the picture that I haven't talked about, and that's the establishment costs of each of the configurations. I plan to talk about that at our next Helios Open Day. You'd be really welcome to attend, and I look forward to seeing you there.
I just wanted to introduce everybody to a new technology that we are using on a lot of orchards in the country. It's called TerraMap. It's our high definition soil mapping system, and it's fitted to a quad bike or a gator that travels up the orchards. The way that it works, it's a completely passive sensor, so it's picking up on natural isotopes that are emitted from the ground, and then we're referencing those isotopes to soil samples from the actual orchards in the row. And so we're able to map about 800 data points a hectare. And from this one pass of the machine, we're able to look at our soil textures, also our percentages of sand, silt and clay, P's and K's, pHs, boron, zinc, copper, organic matter, and also carbon that's in the soil. So from one pass of a soil scanning machine, we're actually able to pick up on a lot more data than traditional systems that have been in the market for a few years now. One of the good things also about it is that the isotopes are incredibly stable, so they don't change much depending on the time of year. So the process that we do is repeatable. So if you were to go back 6 months later, you'd get very similar data. What the calibration samples is it's actually making it more relevant for those trees in those rows. So from this picture here, you can see we can't get directly under the trees or the canopies because the quad bike will damage the trees. We get as close as we can, and then the actual soil samples come from in the row. In terms of widths, depending on the orchards, we try to do every other. If they are tighter packed or it's a cider orchard field or something like that, then it will be every row. It just depends on the spacing in the orchard. It travels at about 10 miles an hour, so you can cover quite a lot of ground in a day. One of the good things as well is that it's not affected by things like forward speed, ground or crop cover. It's not affected by soil moisture. The only thing that affects the scanner on the day is very heavy rain. But if you're on a quad bike, you don't want to be in the heavy rain anyway. So that's the only limiting factor we have. So we can go all year round and target the sort of times that we are in the orchards. In terms of the repeatability, this is one that this was a field that was going into an orchard. So when we first scanned it, it was basically an old arable field. We scanned every 10 meters in September, and then when we went back in March, it had wire work and set up in the field. It had one set of fertilizer applied as well, and we actually used a different scanner. And the type of data we're getting is exactly the same. So it just shows that things that go on in the field that could affect scans aren't affecting the scans of the TerraMap scanner. So it gives us much more reliable data to rely on when doing things such as planning or setting out for new orchards, or looking at data from older orchards that might be 10 years into their lifespan. We're still getting very reliable data on what we're doing. In terms of what the scanner's actually picking up on, there are 3 different services. The first one is a standard service. So this is our PKMGPH, and it also gives you your soil texture. We then have a premium service, which has our organic matter and additional elements, and there is one in between, which is just organic matter and the standard service. You can start to cherry pick certain things if you'd like to. In terms of order size, there isn't a minimum order at the moment on TerraMapping in orchards. We appreciate that some growers may only have a 3-hectare orchard, so to go and put a 50-hectare minimum order in place isn't going to get us very far. So in terms of any orchards that you do have, let us know. We'd be more than happy to come and speak to you about the services that we have available. Just as an example, this is an orchard in Herefordshire. They're split into 4 different varieties of apples across the field. As an example of the sort of data you'll be getting from the scan information, this is an example of our P levels in the orchard. All of this data does go through Omnia. So Omnia is our software system, which I won't go into today, but this produces the variable rate plans if you want variable rate plans, or you can produce paper maps if you want to see how or things you could be doing in the orchard differently. One of the key factors with all the data that's coming from the scans is the relationship between the agronomist and the grower, and also the TerraMap data. So we don't just provide you a file of information and maps and say, get on with it, we leave you to it. We actually give you an agronomist, they'll do all the advice and use the data and interpret the data in the right way. We also have the ability to bring in things like NDVI data, drone imagery data. If you have biomass sensors on your kit or even fruit vision systems, you can bring that into Omnia as well. It's all about layering that data and information to see if there's anything underlying in that orchard that we need to be looking at or doing differently. Again, this is a really key area to look at if you're planning an orchard, and this is where TerraMap's been selling really well, is for orchards that have either been grubbed out and about to be replanted, or for orchards that have been planted on completely new fields that have not been orchards before. I've been through the limitations, so I won't dwell on it. There's a picture of actual kiwi plantation in Herefordshire, one of the only ones in the UK. Just to show that the limitations are very few in between. So I'm trying to slim down to 5 minutes, so I'm not going to dwell massively on those slides. And just to try and keep in with my 5 minutes, it is a new improving sensing technology. So it was launched last year. We've scanned about 400 hectares of orchards. We've scanned about 90,000 hectares of arable land and potato land. All the data is viewable on Omnia. If anybody likes to see any examples or any more information, then please let me know. I was just going to touch on Omnia Access, which is a free portal for anybody looking for a mapping software system to map your farm, map your fields, map your orchards, put in different varieties, create plans. You can mark things like hydrants, water outlets. If you've got any sort of clamp areas, things like that, you can mark those on Omnia. It's completely free to do. Just go to the Omnia website and you can set up an account in a couple of minutes and away you go.